So let's do this one up here. I think this one is probably the easiest. Oh crap. Projectile momentum. I like A-level physics. You
Hello
did good.
students, welcome to the
But
class
this is
again.
pretty clean for what
Last
I'm
class we
looking
talked
for.
about motion in two-dimensional, and I told you about how to find the
Motion in
velocity, how to
two-dimensional
find the
stuff.
acceleration, how to find the
You would be
direction
three-dimensional
when the
now. X,
particle
Y,
was not
Z,
moving in a
or
straight line.
T. You
Rather,
could be
it was
me.
moving
You could be
in
him.
a plane
He
that
could
is
be me,
its
you, or
x-coordinate
anything
and
else. And he
y-coordinate
could be
was
the
changing with
beanball
time.
to the head here
In
on
today's class, we'll
on
discuss
the
about
Hadron
a special
Collider
kind of two-dimensional
umpire.
motion, that is a projectile motion.
It's not.
I have
You could
already
put that
given
on
you a
top of.
description of a projectile
You
motion.
can.
Let us say
And
I have
when
a
you
chalk holder in my
do,
hand,
it works
and now
like
I'm going to
that.
project it at some angle
Standard
which
model.
reaches me here. Now
Not
see, this
conventional
particular
physics.
trajectory is known
Log
as the trajectory of
3,
a
not
projectile,
log 1,
and
2,
it
or
will follow
5.
a parabolic
Right.
path. See how it would look like.
So
Suppose-
lefty up to bat, right? Yeah. Wait.
Let us say the horizontal displacement is given along
Catching
x-axis
the
and the
beanball, I'm
vertical
thinking
displacement
about
is
the
given along
grounding it out,
y-axis.
popping it
The
up, trying to
particle
get
is
those other
moving
numbers from P
along
to
the
N,
two-dimensional
and
space,
P equals wave function.
and it is projected in this direction.
Because
This is the
what
initial
this
velocity which we
is
have
a
given to
projectile. We'll
the
get the
particle.
vertical
Now it
and we'll
was
get the
projected in
horizontal.
this way.
We'll
It
get
will
the
follow
gravity
a
without.
path
We'll get the vertical
given
without
in this
gravity.
figure.
Or no, we'll get gravity because 9.8 meters
Now you
comes
can
from
see
trig.
this path
Theta
is
and
actually look
cosine.
like a circular path, semicircular path, but
Because
that's parabolic path.
you got to figure
will
out
show at
what
the end.
your
Now this was the initial
20
velocity
meters
of
per
the
second
particle.
is throwing a
Let
ball
us say we have
in a
projected
glove
it at
is a
some
whole
angle
operation of
theta with the
generalization
horizontal.
of
So we can
what
say
kind
the
of
initial
throwing ball.
velocity has got
Catcher
two
every
components
time,
as
long as we're using equations like this, yes. So if you're going
and
to
let
use
me
the
mark
base
this
to
as
this
instead of v
equation,
to make
because it
show
is
that
law
it is
of
initial,
the
let us mark it
universe,
as u. This will be u cos theta, and this will be
and you're going to be the little dot down
the
here.
initial velocity
You're
along
going
the
to
vertical
have a lot of
direction will
x's
be
and y's
u
that you're going to throw
sin
together
theta.
like this, like your averages to get
So we can
20
make out the
meters
initial
per
velocity u
second,
cos theta
or
along the x direction
a x
and
mile
it is
an hour
u sin theta
fastball.
along the y
Figure
direction.
out your
Now the particle
coulombs.
is moving along this
We're going
path.
to use
Now this
every
point
time, because 20
is the
meters per
maximum
second
height
make a
point.
10
This is
thing
the
inside
point
here.
of
A special trick from
maximum
A-level
height
physics, a
point,
little
or the
single
highest
stage
point we can
diode
talk
for
about.
electricity
Now,
later.
when it reaches to the ground
But
once again,
You're going to look for
when
a,
it reaches the ground once
Zenith
again,
differences.
this will
This
be the maximum
9
horizontal
meters, it doesn't
displacement, or we
perfectly
can say
arc
this
side,
is the
right?
range
So there are some
of the
anomalies already.
particle. This is the range of
And
the
there's
particle
going to be to the
that
powder. Your
overall during its course of
averages
journey,
of
this is
throwing
the
a
maximum
ball
horizontal
with
displacement.
angle
We can write
are
this as
X and
maximum
Y.
height.
Angle
H.
goes up, powder stays the same,
Now,
right?
at
You know,
any
but over the
instant of
long during the
time,
day,
let us say the
we're going to
particle is
generalize
here.
that, right?
Let
That's
us
half
mark the
that
particle
distance
is
at
here.
this.
Now you see
So
the velocity is
those are
changing
nice and
regularly.
close together.
Let us say this is the
There's
velocity
truth table to
of the
that,
particle
0 and
at
1,
some instant of
later
time,
on.
such that it makes an angle alpha.
So again,
with
you know,
the
lefty or
horizontal.
righty on here
So
is
we will
kind of
have
already
two
described by
components of
delta,
velocity, one along
by
horizontal
gradient,
direction. This
by
component will
a
be
couple
v
of different
cos alpha,
equations,
and this
p
component
over
will be
t
v sin alpha.
greater than
We got this. We got the
h
velocities
over
right.
2.
Now you see here
The kind of something that's happening here.
acting
They
on this
bang
particle.
around.
Now,
They
so
do
the only
they
acceleration
do
acting
you
on the particle will be
your height
g that is
at
acting
throwing
downward.
ball,
So I'm marking
or
the acceleration
arcing.
acting on the particle.
You're trying to
that
go
is
the other way
accelerated
with it
gravity,
for
and
your
it's only acting
math,
along
at
the
least, because
vertical
if
downward
you
direction.
don't ever zenith,
So all the things are clear
it'll
to us.
be either because
Initial
it's
velocity is
too
u cos
wobbly
theta
here,
along x
slow
direction,
motion on
u
the
sin
back
theta
end,
along y
trying to
direction,
pull out
and the
everything.
acceleration acting along the
And
only acceleration acting in this motion is actually to gravity,
that'd
and
be
that is
probably
vertically
one of
downward.
the reasons you lost
Now,
it. But
to study this motion,
if you ever wanted
study
to
the
get to that,
projectile motion,
changing
we
techniques
will
or
break its motion
really
along
getting
two
down
dimensions.
there like that,
That is
nitty-gritty will do
one
that.
along x-axis and one along y-axis.
Some
It will
other
be very
things.
simple as to find out the variables that will be
So
required
again,
for us.
that
What
being
I'm going
the
to do,
whole overall
we are going to
narrative
study the motion
to Bones
one
here,
along
the
x-axis,
pineal gland,
along
and
x-axis
some of the
heading,
point
and the
perspectives
other
can give you
along
again
the
nice little
y-axis
single
heading. Now
stage
you see.
relays, right? X-axis,
The initial
Y-axis,
velocity along the x
multiple
direction
relays,
was given as ux, and this will be equal to u
extra
cos theta
loops and
as per the given
circuitry
variables.
to
Remember, theta is the angle with the horizontal
how
which
that goes
the body was
together.
projected, and the initial
and
velocity
again,
along
your
the
time
vertical
schedules.
direction
This is again
u
for
sin
me
theta.
being a substitute hand model.
Now,
I mean, I could
the
come in
only acceleration
Hemingway,
acting
who
was
the bell
acceleration to
pulls,
gravity, and that was in the
at
vertical downward
what
direction.
angle
So I'm
any
writing
kid could
acceleration
ask
along
you,
y direction as
U,
minus
N,
g,
and
because I'm writing minus
y
because it's acting downward.
is a
So we
field
are
charge
taking
thing,
downward action as
A
negative.
and B.
And here acceleration along
When
x
you're
axis, there's
here,
no acceleration,
it takes
so
a little
zero.
bit to get used to, and it's
Now what
bang,
things
it's
we
fast.
can
Not a lot
find
of
out
people
from
really
this
notice it because
given figure? You
it's
can see that
point
we can
perspective,
find out
right? You know,
the range
it's
of the particle.
okay.
That is the
Am I
maximum
still
horizontal
going to get
displacement.
an
We
A
can find out
as
the
far
maximum
as
height
how far I need to
during its
throw the
motion.
ball as
Now
pitcher?
third thing, we can also find
And
out
that's
the time
0.
of flight. How much time will it would have moved to complete the total range
umpire
of
sitting
its
there on
motion.
charm
So
about
first
what's
thing,
up at the
when
top
it reaches the
of
ground
the
once again, you
forward
see here,
spin mass
it started from
direction,
here. This was
and
its
the
trajectory and it
bottom
reached here.
are going to
When
be
it
your
hit the ground
W
again,
bosons and
its
Z
vertical
bosons
displacement
relative
is
to
zero.
photon gluon, or
So let us say
if
capital
that
T is the
being
time taken to
inverted
reach the
A
ground
anti.
again, and during its time, its vertical displacement became 0. So as it hits ground again,
is a thesis like
As
looking at a run.
hits
How
ground
how far
again.
can you run? Distance quarter mile to 5 miles, or B 0 to a quarter mile to a
y
half a
will be
mile
equal
to
to
3
0.
quarters
Why
of
I'm
a
mentioning
mile
that
to a
because
mile,
vertical displacement that
and
is 0.
age,
So using
right? Like maybe
use
a quarter of a mile, way too much. They're all
S
gassed
equal
out
to
0 on a
ut
phase
plus
operator,
half
not
at
even
square,
in the
you
feeds
can
and
use
speed.
this as S equal to ut plus half at square.
Velocity or laps and loops. So if laps are a quarter mile every day until they can actually do a half mile for
S along y
pace,
direction will come out to be
forward
0.
and back
You know
end
the
of it
value
at the
of
if I only
initial
had a quarter
velocity.
mile,
You know
then
the
the
value
back
of
end
acceleration that's
paces
acting.
are
So with
probably
this,
starting
we
to
can
drift.
find out
Real
the
messy
value
there.
of
If you get truth
time that it
tables
will
and
take to
track this
reach
stuff,
the
like replacing
finally
it
the ground.
in
Let us try to see
stuff, you can't. You can't.
S will be
You
given
could explain
as
that.
0. That keep it as 0. Now U value is U sine theta.
Laps
we are
and
performing
paces for
we are
velocity.
performing all these
So
equations. We are
start
calculating
pace,
along the y
front,
direction. So T
start
plus U sine
point,
theta
the
into
midpoint
T,
distance, mid
and A value
pace
is minus G.
is
So I'm
pace
putting
distance,
this as
total
minus
distance.
half GT square. You can see that TT will be
And
cancelled out.
pace is
So either T will
the
be 0
average
or T will
of
come out to
your
be 2 U
overall
sine theta by Z.
time broke down by
T
the
will come out
most
to be
functionable model,
2U
whether it be
sine theta
one of the small
by
scales
G.
or big scale,
Or
because
we can
there's
write in
0 and
most
1
standard
at
form. Let's
G.
say capital T is the time of flight. So I'm mentioning this
before
as
you get into
capital
C,
T, that is the time
conditions
of
and
flight.
gears.
First thing
So
we
if
got.
it's raining, not raining, night,
T
day,
is equal
hot,
to
cold,
2U sine
change
theta by G.
cleats.
Now all the results that I will be obtaining
When
with
they're
my
generalized
subsequent calculations,
under
I'll be mentioning
the
here
ball.
in this right hand portion. So first thing that
So
we
I'm
got,
having a great time.
that is
Gym's
T
class,
equals to
2 here
2U sine
for
theta by G. Let's
the
keep it
marshmallow mash.
separately at
How
this
far
part
can
of
you
the board.
throw? Mass,
Now,
hydrogen,
second thing what we can evaluate. Now you see here,
1.0078.
again
So we'll
in
make
the
this
figure you
with
see
shot
here,
point put later too, because
at
they're
this point,
even though they're different games,
particle is at
they
its highest point.
can.
At
Now
this
shot
point,
put's actually
the vertical component of
1.06
velocity, the vertical
something
component
else.
of
I don't
velocity
remember
is
exactly
zero.
what the
See
ring
what we can
is.
do
Or
at
what a
this
kid's
point,
one
and
would
you
be,
see more.
but
You see
now
here
that
more.
we get that,
Here,
we can say
the
stuff
body
like that
along
and be
the
like,
horizontal
yes,
direction,
okay.
it has got no acceleration. So we can find out what's the range of
And that's the
particle
amounts
if we
and
use
proportions
u
of
cos
those
theta and
things too,
multiply it
because
with the
molar
total time
masses
taken.
and things.
So now the second
Space
thing
time, what are your
that
conditions
we can
too,
find out as it
barometers,
hits the
that
ground.
matters.
So let's
So
write
that's
here,
A. B ball.
as it
Rock
hits
to
the
1
ground,
gram to 4.5352 kilograms, 10 pounds,
horizontal distance
which
traveled,
consists
let
of
us
shot
mark this
put,
with x.
which changes
This will
the
be equal to
shot put game,
ux
but at the
multiplied
same
by
time there's a parallel
ux
to
is
it.
u
There's
cos
2 to 3
theta,
of them
and
actually,
since there is
but
no acceleration, so we can
that's
directly
at
find out
mass
speed
under
in
and
time,
overhand.
and time was 2u
We're not
sine
just
theta by
talking
g.
about the foot and the throw, but maybe you granny in
See
it,
what will
right?
come
You
out,
just
u into u,
that's
u
the game,
square and
space
2 sine
time.
theta cos theta. If you remember, 2 sine
to
theta
that
cos
is
theta is
baseball
calculated as
to
sine 2
softball.
theta.
It's a composition
This will
thing,
be
inner core, outer
u
core.
square
Because if it was the
sine 2
size of
theta
the
by g.
baseball,
This is the value
at
of
mass or
range.
composition,
So I'm
we
mentioning
have an
capital
outer
X
shell, 2 different barriers where it's not
as
one
equal
piece
to
of
u square
CNC,
sine
steel,
sine 2 theta
baseball,
by
or
g.
softball.
So again we got a
Gold,
second result.
silver,
That's for
nickel,
range.
copper.
So again we are going to use the right hand part of the board. Let us write this result separately. That is range.
Football to frisbee, C, right? At mass,
equal
composition,
to
under and overhand,
u
space time,
square
and conditionals. And so
sine 2
now
theta
one other, we A, B,
by
and C.
g. One more
A, B, and C.
result that we
A
got.
had A, B, and C.
Now
B
the
had
third
A, B,
thing.
and C.
Again,
And
let's
C
come to the
is
figure.
photon and
Third thing is here.
antiphoton. Now,
That's
when
the
we're throwing a
maximum height.
wave,
As I
when
told
we're
you, at
throwing
the point
something
of maximum
that
height, we can see here
is
the body
at
will have
mass
no vertical velocity.
and
Because
composition,
vertical
under and
velocity was
overhand,
responsible to move it in the
something like
vertical
that. I'm
direction.
working
But
on it.
since Here the
I'm
body
working
is changing
backwards
its
to my
direction.
baseball
It's
training.
not able to move in the vertical direction. The only velocity it will be
Stars
having
do,
at this point
and so does
will
the real
be
thing is graphing like that.
horizontal velocity, and that will be equal to u.
So if you had
cos theta,
baseball
that is the
players
only
on,
velocity that is going
winning
to
was
have. That it will be possessing.
players and
So let's
positions.
say
You can have
when
multiple
Vy equals
players,
to
multiple
0,
positions,
what is the
kids stuff
displacement?
as much as baseball
I'm rubbing
team,
this part.
math players. Some drills, right? You're gonna draw out some drills. Flat and square.
Position
Just
of
doing
maximum
this.
height.
That game becomes very different.
At the position of maximum
What
height.
is a strike?
At
Give all the rules, just fundamentals,
maximum
some drawing, some
height
perspectives
position, or
too,
you can say
because
at
this stuff
highest point.
is actually
At
where I
maximum height
learned to
position,
get good with geometry.
we can
And
write
geometry
Vy is
gets
equal to
good
0.
with
Vy equals to
perspective.
0. Now you know
And
that use
CMB
v
stuff
square is equal to
and
u square
values
minus
at that
2as
place, top of the
using
shoulders, mid body, that works up. You know what I mean? So
v square is equal to u square
the rules of
minus
the
2as, or
of the
let's say in standard form
bunks,
plus 2as,
the
and let's
the
substitute
block,
the values.
yeah, drop the ball.
Vy whole square
As much
is
as
equal to
that
uy
is,
whole square,
when you think
and
about how to throw a
minus
ball,
2g
to break
h
it
I'm using for
down,
maximum height.
and
See, Vy
this
was
is very good.
Vy
I
will
mean,
be 0.
I already got a thumbs
Uy
up. So
will be u sine theta
you'll see pitches like this a
whole
lot,
square
and
minus 2
lots of
g
theses.
capital H.
This one
Now you see
itself
here,
is
just
not the main
evaluate the
line
value
for
of
it.
capital H. You
That's
will
more
be
like a
obtaining
Birkenjack
capital H will
conjecture
come out to
or
be
Bell's inequality or something like that, where
u square
you really
sine
have to
square
think
theta
about not
by
just
2g.
the
This is the
equation,
value
but
of
this equation.
maximum height that we have obtained. So let's write this result also at this in this part of the board.
Rules
Third
of
is
warming up,
maximum height
pre-game
with capital
stuff.
H max. That
Of course,
came out to be
soccer not going to be far off
u
with
square
again the kids to adult
sine square
models
theta
on
by 2g.
figuring out some YouTubers,
check it.
right? You know,
U
get
square
them in
sine
there.
square theta by 2g,
You
that
take
is the
this
value of
projectile equation
maximum height
and
that we have obtained.
you slide. I don't know.
Let us have a
Wait, this
quick
is
revision of the three formula that we have
substitute
derived.
teacher
T equals to 2
supposed
sine
to be
theta by g.
model. Like that's a
Second
lot
range,
to
r
unknow.
equals to u square sine 2 theta by g. Third, h max equal to u square sine square theta by 2g. In this, all these
again,
three equations, I will
just to end
request you
here,
all.
it
Do
can
remember,
be
try to by heart all
so
these three
important
basic equations
in
by
getting
any
this
means.
stuff
Now see,
going.
if you
So.
suppose you forget, what to do?